Hi, this video discusses returns to scale, explains the three types of returns to scale that we have, and shows you how you calculate returns to scale when you have a Cobb-Douglas production technology. First, let's talk about what returns to scale are. It will tell you how your output changes if a firm increases all of its inputs by the same proportion. So you have three different types of returns to scale you could have. You could have increasing returns to scale. This is the case where, for example, if you were to double your inputs and your output would more than double. You could have a decreasing returns to scale, in which case, if you double your inputs, now your output would less than double. Or the third scenario you could have, if you were to double your inputs, is your output exactly doubles. This is the case of constant returns to scale. So note, decreasing returns to scale, if you increase your inputs, the output increases. It just doesn't increase by the same proportion that your input increased by. Now, let's talk about what this would look like for each of these cases. Okay, so using this proportional increase, and we're going to double again. So if you have your function, which is your output is a function of labor and capital, and you decide to double both of these, and you have a constant returns to scale, that's the same as twice whatever your production function is. So your output doubles on the right-hand side, your inputs are being doubled, and those are equal. Now, what if they're not equal? Okay, what if you double your inputs? The amount of output that you get from doubling your inputs exceeds the output you would get, which is simply twice as large as your output, 2 times whatever your production function gives you. This is a definition of increasing returns to scale, where doubling your inputs gets you a larger output than simply 2 times whatever your output is. Or you could have the decreasing returns to scale case. In this case, you have whatever output you get when you have doubled your inputs, that's going to be smaller than simply doubling your output. Okay, so this is a case where your output less than doubles. So let's talk about this in terms of the Cobb-Douglas production function. You have your output as a function of some parameter multiplied by labor, which is raised to the alpha, times capital, which is raised to the beta. So your gamma, adding up your superscripts, this will tell you your returns to scale. If your alpha plus your beta sum up to 1, your gamma is equal to 1, then you have a constant returns to scale production function when you have a Cobb-Douglas production technology. If your gamma exceeds 1, your superscripts add up to a number that's bigger than 1, you have an increase in returns to scale. And finally, if your gamma, adding up your alpha and your beta, add up to a number that's less than 1, this is an example of a decrease in returns to scale. Okay, so let's work through a few examples to illustrate how we would use this alpha plus beta adding up to get gamma in order to determine the returns to scale. So in this first example, we have 10 to the times k to the square root times l to the square root. Well, this is a alpha and beta of 1/2 each. So you adding those up, you get 1. So since gamma equals 1, this is a constant returns to scale function. The second example we have also is a Cobb-Douglas production function, which these superscripts are 1 each. You add those up, you get 2. So this is a increase in returns to scale production function. This one, you have k raised to the 1, l to the negative 1. So this is 1 plus a negative 1 gets you 0. This is an example of a decrease in returns to scale production function. And this fourth and final case is not a Cobb-Douglas production function technology because this is additive and not multiplicative here. So we can't use that Cobb-Douglas approach, production function approach of adding up our superscripts. So here we've got to go old school. What I mean by that is you've got to plug in values for k and l. Let's let them each be 1, for example. If you let them both be 1, then you would have 10 times 1 is 10, plus 2 times 1. That would get you 12. if you have K and L of 1. Now let's double our inputs. Let K be 2 and L be 2. In that case, you'd have 10 times 2, which is 20, and you'd have plus a 2 times a 2, which is 4. That would get you 24. So we have doubled our inputs. We've doubled K and L, started at 1. We doubled them to 2, and we have our output doubles. So this is an example of a constant returns to scale technology.